Hello everyone. For my last few tutorials on real-life physics, I like to talk about electricity and magnetism, as well as give a more in-depth explanation of how the electromagnetic spectrum actually works. The most simplest electricity concept involves still electricity or static electricity rather than electricity that flows in a circuit. You may have often heard static electricity discussed in contexts of science fiction movies, or seen famous images of people with their hair sticking out from static electricity. But real-life static electricity is a lot more complicated than the stereotypes you will often see in popular media, and depends entirely on the materials in question involved. Evidence of static electricity is derived from using different materials and rubbing them against one another, and noticing how one type of material develops a positive charge and the other material a negative charge, and they repel each other naturally. A common example is glass rubbed on silk, where the glass is positive and the silk is negative. Another example is clothes rubbed together in a dryer, which you probably already have real-life experience with, and it is the reason why you put sheets between your clothes and the dryer. Although these are usually the obvious examples of static electricity, great thinkers like Benjamin Franklin considered more in-depth questions about how exactly static electricity works regardless of the materials involved. You may have often seen in science classes and as a general portrayal in the popular media a picture of an atom that looks like this, which is actually a more simplified interpretation of it. It's not exactly like how an atom looks. What the important part of this diagram is the parts on the outer shell, which are known as electrons, which comes from the Greek word electron, meaning amber, as a reference to the power and energy they supply. And then, in the inner circle of the atom, there are protons and neutrons, which have a positive charge and no charge, respectively. And their name comes from the fact that electrons were discovered earlier, and so they were given similar names to keep the pattern consistent, where the pro prefix in proton means positive, as it usually means, and the nu prefix is shorthanded for neutral. Interestingly enough, even though protons are more massive than electrons, each proton has exactly the same amount of charge as each electron, even though their masses and locations are very different. And there's actually a specific number for the charge of one single electron or proton, which is this, and it is given an SI unit of coulombs after the physicist who first discovered it, because Franklin did not know about how exactly electrons work, nor did he know how to measure their charge. He just knew that there had to be some concrete reason that lightning got attracted to the key in his kite. We can see, based off this definition of the charge of one proton or electron, for a charge of 1 coulomb exactly, we need exactly this much protons for the math to work out. And the charge of a single electron is not an arbitrary number, but was concretely measured by Coulomb himself. So this number does accurately describe how charge works. As you probably already know from physical science and/or chemistry, different materials more or less readily give up electrons than other materials, and this is the exact logic behind how static electricity works. Because of the fact protons and electrons are retained even when they move between different materials, the total charge in a system stays exactly the same, and this is called the law of conservation of charge. Although static electricity is very messy in that it depends on the materials in question involved, and there's no neat way to predict how it will work, many scientists and engineers have already figured out how it works for you, and have given specific names to materials depending on how well they conduct electricity, aka give up electrons. And this will be the subject of the next tutorial video, when I explain how conductors and insulators work. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos and follow me on either Facebook or Twitter for more content.